Welcome to my channel STEM Cafe, where we make everything science, technology, engineering, and mathematics easy to comprehend, understand, assimilate, recall. We make everything STEM fun. Today, we are studying linear, simultaneous, quadratic, and polynomial equations. The main target is polynomial equations, but these are the prerequisites to polynomial equations. Let's start with linear equations. Linear equations. When we were in lower classes, we were taught or we were asked, if you buy goods that are worth like 3 goods, each worth $3, and you are paying $10, how much are we expected to collect as our balance? So what are we going to have? This is how it is represented most times. 3 times 3. Or we have something like this. 10 minus this. 3 times 3 for the goods. So this is the basic thing. This is all we are doing in linear equations. But in this instance, when you are having linear equation, we don't use box any longer. Most times we don't use box. So we use letters. So now we can just say letters. Now we can say 10 minus y is equal to 3 times 3. Or this 3 times 3 minus plus y is equal to 10. That is our balance. So for anybody handling the linear equation, this is all you need to understand about it. We just need to understand procedures to handle bigger figures and higher volume of items. That's all. Or that activity that involves many other quantities. These are the things that we use. We have something we call coefficients. We have variables. And sometimes we have constants. These coefficients are attached to the variables. And what are the variables? The variables are represented by letters. These coefficients are constants. These coefficients are figures. Let me put it like that. These are figures. This can be represented by letters, boxes, and these are non-changing constants. So with the combination of this, we'll be able to get our answer. Now, the combination of coefficients and variables gives us what we call terms. Coefficients and variables give us terms. So linear equation is combination of terms. Linear equation is combination of terms that gives us expression. Let's see what it's like. Now, if I have an expression like this, 5y plus 10x is equal to 17. This 5y is a term. 10x is a term. And you know this one is a constant. In this term, 5y, 5 is the coefficient. Y is the variable. Why do we call it variable? It can have any value. It can have any value. Likewise, 10x. 10 is the coefficient, while x is the variable. Now, in handling expressions like this, we might have similar terms. Like if I have something like this, 5y, 10y, 3y, 2y, they are all like terms. You can see. What do we mean? If y represents specific quantity or good, it means that 5y is 5 multiplied by y. 10 is 10 of y. 3 of y. 2 of y. I can easily add this. I can easily subtract. I can easily perform any mathematical operation with this. Now, if I have something like this, 5y, 10xy, these are not like terms that I can have. I cannot add this and bring out any kind of figure with this. The only thing is that I can factorize. That is bringing out the factors. You remember our common factor, LCM, HCF. So in this instance, if I have a situation like this, 5y plus 10xy, you can see that this one is a common factor. 5 is common to both. Y is common to both. So I can now say 1 plus 2x. That's the only operation I can perform with this. That is the only operation I can. So what I need you to understand is term, coefficient, variable, and like terms. So with this, you can start our operation. I want you to understand, to know one important rule. One important rule in handling linear equations. We have equations like this. Right hand side equals left hand side. That's what we have. The most important rule is whatever you do to the right hand side, whatever operation carried out on the right hand side must be carried out on the left hand side. Please note, sometimes you might see some operations being done without writing anything. It's because they have become subconscious, unconscious to the one performing it due to experience. So if you add on the right hand side, if you add anything to the right hand side, you must add it to the left hand side. If you subtract from the right hand side too, subtract anything from the right hand side, you must do it to the left hand side. If you divide, which means when you are dividing, you don't just divide one portion, you must divide all through. Divide all through on right hand side, you must divide all through on the left hand side. If you multiply, that is, you decide to, you are importing this thing on your own. That's what you are saying now, not whatever that is already in the operation. You are trying to bring in a way of solving the linear equation. You are the one importing this thing, not that it is already there. When we perform our operation, you see, multiply through. This one, you are the one doing it all through on the right hand side. You must multiply through on the left hand side. That is all that it entails. That's all. And why do we do this? We are trying to gather the constants or certain like terms. The process, the essence of this is to gather like terms to one side or separate for ease in solving. That's all the rule. That's all it entails. And from this, we can go on to handling some examples. Now, please, before we go on, I'd like to appeal to you. If you have not subscribed, kindly subscribe. Assist to share, to let others know about this. And those who have done so, please, we appreciate all your efforts. And also make comments, please. Now, let's go back to the lecture. I want you to know, before we continue, that linear equations can be added, can be subtracted from one another. We can multiply, and we can divide, either with another linear equation or constants. So let's look at this example. You can see we have 6x plus 7, that's the linear equation. 5x minus 2, that's another linear equation. 4x minus 1 is a linear equation, is equal to 36 plus 7x. Generally, in linear equation, we are always looking for one unknown, and the unknown in this situation is x. So generally, that's what we do in linear equation. Now, let's look at this. We can now have 6x plus 7 plus 5x minus 2 plus 4x minus 1 is equal to 36 plus 7x. You have to remove the bracket first before you can continue the operation. Because sometimes they might have some constant outside which we need to use to multiply everything in the brackets. In the other examples we see. Now I talk about like terms. Let's look at the like terms here. 6x, 5x, 4x, they contain x, so they are like terms. So let's gather them. 6x plus 5x plus 4x. And look at this one, the constant 7 minus 2 minus 1. So we have plus 7 minus 2 minus 1 is equal to 37 plus 7x. Now 6 plus 5x plus 4x, that's 15x. 7 minus 2 minus 1, that is plus 4, is equal to 36 plus 7x. Remember our rule, that whatever you do to the right hand side, you must do it to the left hand side, which you bring into the operation. Every other thing that you have done, they are already embedded in the equation. So now I am trying to gather the x terms to one side and the constant to certain side. So the first thing I do is I will subtract 7x from both sides. Why? To neutralize the 7x in, so that this place will no longer contain 7x. Look at what I did. 15x minus 7x plus 4 is equal to 36 plus 7x minus 7x. Looking at this, you can see that the x terms have been neutralized. And here, what do I have? I have 8x plus 4 equals 36. Now, to move this away, I will subtract 4 from both sides. So what do I do? 8x plus 4 minus 4 is equal to 36 minus 4. So what? Because I am the one that's bringing this one here, I have to do it at this place too. So here, I have 8x is equal to 32. Now, this one, I have to do it now. To have x alone, I will divide both sides by 8. I'm the one importing it into the equation. So I have to do it to both sides. So divide both sides by 8. I have 8x divided by 8 is equal to 32 divided by 8. So what do I have now? And that is 4. So x will be equal to 4. So most times, once you have gotten your answer, put it back into the equation. If it gives you, if the right hand side equals to the left hand side, it shows that you have gotten the answer. Now let's substitute it into our equation. Look at this. 6x will be 24 plus 7. 5x, that's 20 minus 2. 4x, that is 16 minus 1. And what does that give us? This one is 31 plus 18 plus 15. So 31 plus 15, that is 46. 46, that's 64. Now, this side is 36. And this one is 7 times 4, 28. This place is 64. So we show that our answer is correct. So this is the right hand side, and this is the left hand side. So once you finish your linear equation, it's always advisable to substitute whatever you get back into the equation, and that shows that your answer is right or wrong. Now, let's look at this. We have 5 into x minus 1 bracket plus 3 into 2x plus 9 bracket minus 2 plus 4 into 3x minus 1 bracket plus 2 into 4x plus 3 bracketed. Now, I've said it before that you need to open the brackets before you continue. That's the first thing, just like God maths. This time around, I will multiply this one by the 5 that is outside. You know, it is already in the equation. So, it's not that what I do here, I will do it here now. This one is already part of the equation. It's only what I import out of my own ingenuity to solve the equation, that whatever I do to the right side, that I do to the left hand side. Now, for this one now, I have to expand. So I have 5 into x minus 1, that is 5x minus 5 plus 3 into 2x, that's 6x. 3 into 9, that is 27. Minus 2. Here. Now, please, I want you to understand, when you are opening a bracket, whatever that is outside, you must use it to multiply everything that is within the brackets. What is here, I use it to multiply everything that is within the brackets separately, and I brought it out, please. So here, we have 4 into 3x minus 1. So 4 times 3x, that's 12x minus 4. This one is 8x plus 6. You can see. Now from here, I can now gather like terms. I have 5x and 6x minus 5 plus 27. You can see. Minus 2 is equal to this one, 12x plus 8x minus 4 plus 6. Now 5x plus 6x, that is 11x. Minus 5 plus 27 minus 2, that is plus 20. And this one is 12x plus 8x, that's 20x. Minus 4 plus 6, that's plus 2. You can see. Now, to make it easy for me now, let me subtract 11x from both sides. You can see I am the one bringing in this operation into the equation. So I have 11x minus 11x plus 20. So this one is to neutralize this one so that I have all the x in one side. Is equal to 20x minus 11x plus 2. So what do I have? I have 20 is equal to 9x plus 2. Now, what do I do to remove this 2 from this side? I will subtract 2 from both sides. What does that do? 20 minus 2 is equal to 9x plus 2 minus 2. So I have 18 equals to 9x. Now, to find x, I have to divide both sides by 9. So I have 18 divided by 9 is equal to 9x divided by 9. So 2 is equal to x. Or x equals to 2. Simple. That's the answer. That's our objective. We have achieved it. So to really prove that, oh, I've gotten my answer, I can bring this 2 into this initial equation. If the right hand side gives me the left hand side, simple. It means I've gotten my answer. Let's see how that goes. I won't always do this, but I'm just telling you. So for this one, maybe this will be last. So 5 into 2 minus 1 plus 3 into 2 into 2 plus 9 minus 2. Let's see what this gives. This one is 1. 5 times 1, 5. Plus, this one is 4 plus 9, 13. 13 times 3, 39. Minus 2. What does that give me? 42. You can see, that is the right hand side. That's what the left hand side will be. Now, for the right hand side, I have 4 into 3 times 2, 6. Minus 1. Plus 2. What is 4 times 2? 8. Plus 3. So, what does that give me? 4 times 5, that's 20. 8 plus 3, 11 times 2, 22. And that one is also 42. So right hand side, you can see, right hand side and left hand side are equal. Now from the previous examples, you have seen that we can multiply linear equation by constants. We can add 2 linear equations, we can subtract 2 linear equations. But in this instance, how do we go about, when we see 2 linear equations and we have to multiply them, how do we go about it? Just let's look at how to simplify the handling of it. Now, if I have an expression like 7 times 9, you know that one will give me 63. I can break this 7 down. Let me say 4 plus 3. And this 9, I can say 7 plus 2. You understand? If I want to, at the end of the day, if I should multiply these 2, it must give me 63. Now, how do I go about it? It will be this first one, I will use it to multiply everything in this bracket. Then, I will now add it to this one and multiply it with everything in the second bracket. You can see. So, this will now be equal to 4 times 7, 28. Plus 4 times 2, 8. 3 times 7, 21. Plus 3 times 2, 6. And that's going to give me 36 plus 27. And what does that give me? 63. You can see. So when you want to add the multiplication of 2 linear equations, you have to take one and use it to multiply everything in the second bracket. Take the second one. Even if it is 3, 4, you have to do it like that, all through. So if you have an expression like this, ax plus b into cx plus d. So what do? We are going to have ax into cx plus d plus b into cx plus d. That is a simple way of handling it. Another way I used to handle it is I make a table like this and I write everything here out. Ax. I will include the sign in every part. I will put the sign plus b. You can see. If it is positive, you don't necessarily need to put the sign. So let's look at this one. So cx d. So you can see, at the end of the day, what are you going to have? You just fill in these boxes and then you add the terms, the like terms. So look at this one. It's going to give me ac x squared plus bcx. This one now is going to give me adx BD. So if there is negative sign here, you have to input it. You have to put it. So because these ones are positive, that's why it's easy like this. So all I just need to do is to gather the like terms. So this one is going to be AC x squared plus, if you look at this one, x into BC plus AD plus BD. So for me, this is my preferred procedure. It depends on you. Another way you can do it is, you can say AX plus B times, like you do our normal multiplication, we just shift this one here, CX plus D. So you now take it one after the other. CX and AX, everything is the same, depending on how you look at it. So this one will now give me AC x squared plus BCX. D now, I will now use it to add, so it will be ADX plus BD. Now, I just bring out the total here. AC x squared plus x into BC plus AD plus BD. So you can see, it brings you the same answer, depending on what you would like to do about it. Depends on your own flair for any technique. And I'd like to teach you a simple shortcut. A simple shortcut now. Please kindly like, share, make comments, and introduce other people to this our channel. Thank you. So about the shortcut I want to tell you. If you have something like this, x plus a and x plus b, please note, in this instance, the coefficient of x is 1. The coefficient of x here is also 1. Now, let me expand this. At the end of the day, I'm going to have x squared plus a plus b x plus ad. You can see. So when you don't need to go how do I put it? That lengthy technique. Once you can see that the coefficient of x in both is 1. So all you just need to do is x squared, add the constants, multiply by x, and then product of the constants. Let's see what I just done. So x into x plus b plus a into x plus b. So what does that give me? X squared plus bx plus ax plus ab. So this one is now going to give me x squared plus a plus bx plus ab. So you can see. So once even if it's not having one here, if you can make it by dividing through and putting the constant outside. You can do that, and later on multiply through by the constant, depending on you, please. But so once the constant of the x are 1, you can just go straight to the expansion and you get your answer. Now, with this, we'll be able to solve our next example. Now we have another example now. 4x plus 1 brackets multiplied by x plus 3 minus x plus 5 into x minus 3 equals 3x plus 1 bracket into multiplied by x minus 4. Now, you can do any form of expansion, but the shortcut to solve this, you can just make it like this. 4 into x plus 1 over 4 into x plus 3 minus x plus 5 into x minus 3 is equal to 3 into x plus 1 over 3 into x minus 4. What am I trying to achieve? I want to make the coefficient of all the x 1. And from the simple expansion I showed the other time, this one is going to be 4 into x squared. What is the sum? 3 plus 1 over 4. That will be 13 over 4. 3 plus 1 over 4. That will be, okay, let me put it like this. 3 plus 1 over 4x plus 3 times 1 over 4, that's 3 over 4. Yes, that was straightforward. Minus x squared. So this one will be plus 5 minus 3x. What's the product? Minus 15. Minus 3 times 5. So this one is. Now let's look at this one. This one is going to be 3 into x squared plus 1 over 3 minus 4 minus 4 over 3. Please, I hope you are following. This one is 1 over 3. This one is minus 4. That's why I got that one. Now, let me break it down further. 4 into x squared. That is plus 13 over 4 plus 3 over 4 minus x squared. That one is 2x plus 2x minus 15 is equal to 3 into x squared. This one is going to be 11 minus 11 over 3 x. Oh, sorry, x to be here, please. X minus 4 over 3. Now, let's see. So this one at the end of the day is going to give me 4x squared plus 13 plus 13x. Oh, sorry. Plus 13x plus 3. 4x squared. So this one will be minus x squared minus 2x plus 15 will be equal to 3x squared minus 11x minus 4. So you can see, it makes it simple. Then, what do I do next? 4x squared minus, because these are the terms, I have to bring them together. So I have 4x squared minus x squared plus 13x minus 2x plus 3 plus 15 is equal to 3x squared minus 11x minus 4. So this one is giving me 3x squared, 13x minus 2x plus 11x plus 18 is equal to 3x squared minus 11x minus 4. Now, I have to start using my own ingenuity to solve this. Let's start by subtracting 3x from both sides. Subtract 3x squared from both sides. So I have 3x squared minus 3x squared plus 11x plus 18 is equal to 3x squared minus 3x squared minus 11x minus 4. So that gives me 11x plus 18 is equal to minus 11x minus 4. Now, to make this one simple, let me add 11x to both sides. Add 11x to both sides. So what do I have? 11x plus 11x plus 18 is equal to minus 11x plus 11x minus 4. That 11x is added to neutralize this one. So I have 22x plus 18 is equal to minus 4. Now, to remove this 18 from this side, what do? I subtract 18 from both sides. So what does that give me? 22x plus 18 minus 18 is equal to minus 4 minus 18. So the next thing now is I have 22x is equal to minus 22. 22x is equal to minus 22. Now, I have to divide both sides by 22. Divide both sides by 22. So what does that give me? 22x over 22 is equal to minus 22 over 22. Therefore, x is equal to minus 1. You can see, very straightforward. All you need to do is to take your steps with care and follow the necessary procedures. That's all. We have another expression here. X plus 2 over 2 minus x plus 5 over 3 is equal to 2x minus 5 over 4 plus x plus 3 over 6. In this instance, just like any fraction, when we are having fractions of different denominators, what do? We look for LCM. And in this instance, we can find the common multiple of this one, even the lowest. And if you look at this, the lowest is 12. Now, since we have found the lowest, for ease, let's multiply through by the LCM. Multiply through by 12. So what are we going to have? We are going to have 12 into x plus 2 over 2 minus 12 into x plus 5 over 3 is equal to 12 into 2x minus 5 over 4 plus 12 into x plus 3 over 6. Now this one gives me 6 here. 4, 3, and 2. So from here I can now expand straight. You can write it out, you can expand straight from here. So I have 6x plus 12 minus 4x minus 20. Please take note. The sign changes because of this. Will be equal to 6x minus 15 plus 2x plus 6. Now gather the like terms. So we have 6x minus 4x plus 12 minus 20 will be equal to 6x plus 2x minus 15 plus 6. So I have 2x minus 8 is equal to 8x minus 9. Now, for ease, let me subtract 2x from both sides. 2x from both sides. So I'm going to have 2x minus 2x minus 8 is equal to 8x minus 2x minus 9. So I have minus 8 is equal to 8x is equal to 6x minus 9. Now, to remove this to this side, what do? I will add 9x to both sides. Oh, sorry, add 9 to both sides. Add 9 to both sides. So I'm going to have minus 8 plus 9 is equal to 6x minus 9 plus 9. So this one gives me 1 is equal to 6x. Now to find what x is, I have to divide both sides by 6. Divide both sides by 6. So I'm going to have it like this. 1 over 6 is equal to 6x over 6. So x is equal to 1 over 6. That's the answer. Now let's do one more before we go to the next section. Now let's look at this. We have 3 divided by x minus 2 plus 5 divided by x minus 3 minus 8 divided by x plus 3 equals 0. Now, the LCM for the denominator will be the product of all denominators. X minus 2 into x minus 3 into x plus 3. With experience, you can cancel this out and go to the next step. But being that we are using it as one example, we do this one. Multiply 2 by LCM. By LCM. So I'm going to have x minus 2, x minus 3, x plus 3 times 3 over x minus 2 plus x minus 2, x minus 3, x plus 3 into 5 over x minus 3 minus x minus 2, x minus 3, x plus 3 divided by 8 over x plus 3. Now you can see it's very easy to now divide. You can cut like this, you can cut like this, and you can cut like this. So what do we have now? We have 3 into x minus 3, x plus 3, plus 5 into x minus 2, x plus 3, minus 8 into x minus 2, x minus 3 is equal to 0. Is equal to 0. Now, as you have known before, we can expand this one easily. So how do I go about that? 3 into x squared plus minus 3 plus 3 into x minus 9 plus 5 into x squared plus minus 2 plus 3 into x minus 6 minus 8 into x squared plus minus 2 minus 3 into x plus 6 is equal to 0. You can see. So this one we cancel out. Okay, let me do it again. So I have 3 into x squared minus 3 plus 3 is 0 minus 9 plus 5 into x squared. This one minus 2 plus 3 is 1. So that will give me plus x minus 6 minus 8 into x squared minus 5x plus minus 2 minus 3 is minus 5 plus 6 will give us 0. Now with this I can easily expand. So I have 3x squared in minus 27 plus 5x squared plus 5x minus 30 minus 8x squared plus 40x minus 48 equals 0. Now let's gather the like terms. 3x squared plus 5x squared minus 8x squared. Now minus, so I have plus 5x plus 40x minus 27 minus 30 minus 48 minus 48, yes, is equal to 0. Now if you look at this one cancels out. 3x squared plus 5x squared is 8 minus 8x squared. So this one is going to give me 45x. And this one is 27 plus this one minus, that's 75, that is minus 105 equals 0. So the next step is to add 105 to both sides. Add 105 to both sides. So I can say 45x minus 105 is equal plus 105 is equal to 0 plus 105. So I can now say 45x is equal to 105. Now, the next step is to divide both sides by 45. Divide both sides by 45. Now, I can do that here. So I can say 45x over 45 is equal to 105 over 45. This one cancels this. 5 here, 9. 5 here is 21. So I can still divide by 3. 3 here, 3. 3 here, 7. So x is equal to 7 over 3. That's the answer. So you just follow through step by step. You get to your final destination. And be careful of the signs and multiplying in expanding the brackets. That's all. Now the next to handle is simultaneous equation. And why do we call it simultaneous equation? We have, in this situation, we need to have more than one equation because we are looking for two or more variables. Two or more variables. And which means that the variables must exist in at least two or more equations where they will act concurrently. That's why we refer to it as simultaneous equation. How do I mean? In this situation, we are looking for x and y. It means that we need to get two equations that where x and y will be operating. Like if we say 4x plus 3y is equal to 10. And we can now say 6x plus 8y is equal to 17. You can see we have the equation in x and y here. We have the equation in x and y here. The truth is sometimes it's not necessary that the second equation will comprise the two variables. But at least you need two equations. That is the important thing to note. Sometimes you can have it in x, y, z. You can say 4x plus 3y plus 2z is equal to 10. 5x plus 4y plus z is equal to 12. With this, you can't solve this. We will need at least one more, where they will act in different manner together to give us another answer. So we might need to have something like 7x plus 2y plus 5z is equal to 10. So you can see, with this one we can solve for x and y. With this one we can solve for x, y, and z. That is why we refer to it as simultaneous equation. Under certain circumstances, we might not be able to get the solution. Like, look at this. We have 4x plus 2y is equal to 7. I now have 2x plus y is equal to 4. I can't solve this one. You know why? Look at the coefficients. 2 over 4 is equal to 1 over 2 here. So, which means I will not be able to solve this kind of simultaneous equation. So, they must act in different manner to give me different answers. That is the only way I can get my answers. Now, let's look at the main ways to solve simultaneous equation. The first one is what we refer to as let me see. We call it elimination method. Elimination method. For me, this is the most important technique you need to know about this. Why? It is very easy to use when you want to solve 2 above 2. Very easy to use. But it depends on you. I've seen people that say, no, I don't like using this. I like using simultaneous substitution method. In this instance, what do? we try to equate coefficients of certain variables in two equations to eliminate that variable in order to reduce our unknown. Let's say we have an equation like this. 2x plus 3y is equal to 7. I have 3x plus y is equal to 12. In elimination method, what do? Either here or here. Let me say I want to eliminate x. I want to eliminate y. To eliminate y now, I will make the coefficients of y to be equal in the two equations. And the easiest way to do that is to multiply the second equation by 3, sorry. Is to multiply the second equation by 3. So let's look at what it will be. It will become 2x plus 3y is equal to 7. So this one will now be 9x plus 3y is equal to 36. You can see now. So conveniently, I can subtract this one from this one, and it will be my result will be in x only. Let's see. If I subtract this one from this one, I'm going to have minus 7x. This one is 0 now. Will be equal to 7. That will be minus 29. So you see, from here I can conveniently solve this equation here. I can conveniently solve for x now. Let me keep this. Let's use it for our next technique. Now, the next one is substitution method. In this substitution method, we make one of the unknown or variable the subject of the expression in one of the equations. Look at the step. First of all, make one the subject of the expression, and then the second step is to substitute in the other equation. This one is very easy. When your unknowns are just 2. Let's do the previous example. I have 2x plus 3y equals to 7. 3x plus y is equal to 12. Now from here, I can make y the subject of the formula. So most times we number our equation. So I now say y is equal to 12 minus 3x from 2. Since I have made y the subject of my formula from 2, I will have to substitute this in the expression in the first one now. If it is from the first expression, I make my x or y the subject of the formula, I will have to use it in the second expression. Please take note. Now, I will now put this one here. It's now going to give me 2x plus 3 into 12 minus 3x equals 7. You can see. Now, what do I have? I have 2x plus 36 minus 9x is equal to 7. So I have minus 7x plus 36 equals 7. So what do I do next? I subtract 36 from both sides. Subtract 36 from both sides. So I have minus 7x plus 36 minus 36 is equal to 7 minus 36. So you can see minus 7x is equal to minus 29. Just like we had previously. You can see. Now, the next technique. This one is just, most times we use it in our experiments, in our gathering of parts and whatever. We use graphs. So what do? Sometimes we make tables. And then we just plot graph for each. Most times this one might involve substitution method. So what does that mean? You make tables involving x and y, and then you plot the graph. At the point of intersection, you find the x and y. So that gives you the answer. So these techniques we are given, you can use it for linear, simultaneous linear, quadratic, sometimes you can get equations involving linear and quadratic and any form, either polynomial also. So it's easy and you use it. I mean the three techniques, they are very, very useful. And what you have learned now, the linear equations, simultaneous equation, especially the linear equation, nobody lives a day without using linear equation. I can assure you that. When you spend, even in your working, even in your drinking, when you drink water, you drink certain quantity and some remains. Sometimes you drink water, you still need more. Everything is about linear equation. Now let's work some examples in this. Now let's look at this example. Here we are handling two unknowns. Two unknowns. Here we have 5x plus 2y equals to 14. 3x minus 4y equals to 24. So let's call this one our first equation, second equation. Now, if you look at this, the LCM of this is 4. So all I need to do to make the coefficient of y to be equal to 4 is multiply the first equation by 2. So let me just put it like this, times 2. And that will give me 10x plus 4y is equal to 28. You can see. Now, I have minus here, I have plus here. To cancel this, all I need to do is to add the 2. Sometimes you might have plus here and plus here. In that instance, you will need to subtract the two equations. So I can call this one 3. Now, then, to cancel the y now, I will say add 2 to 3. What does that give me? 3 plus 10, that's 13x. This one cancels. Now, 24 plus 28, that is 52. So, to find x, I will divide both sides by 13. So I have 13x over 13 is equal to 52 over 13. So what does that give me? That one gives me 4. So x equals 4. Now to find y, it's very easy now. I will just substitute x, 4 for x in either of the equations. So I can now say substitute 4 for x in 1. So what does that mean? I'm going to have it like this: 5 to 4 plus 2y is equal to 14. And this one gives me 20 plus 2y equals 14. Now to solve this, what do I need to do? I will need to subtract 20 from both sides. Subtract 20 from both sides. So that's going to give me 20 minus 20 plus 2y is equal to 14 minus 20. And that will give me 2y is equal to minus 6. 2y equals minus 6. Then divide both sides by 2. Divide both sides by 2. So I have 2y over 2 is equal to minus 6 over 2. So y will be equal to minus 3. Just like we did in linear equations, we can do it here too. Since I substituted this in the first one, let us now put the value for x and y in the second equation to confirm. So the left hand side now, what does that give me? It's going to give me 3 into, I think, 4 minus 4 into minus 3. And what does that give me? This is 12 plus 12. That gives me 24. So which is the answers are correct. Now let's do another one. In that place, I will use substitution method. Now we have this 7x minus 4y equals to 23. First one. 4x minus 3y is equal to 11. The second one. Now we are using substitution method or technique. Now I can use this first one or second one and then make any of them the subjects of the equation. Let me use the first one. From the first equation, 7x is equal to 23 plus 4y. Then x will be equal to 23 plus 4y divided by 7. So you can see that is from the first equation there. The next step is to substitute this for x in the second equation. Therefore I can say substitute 23 plus 4y over 7 for x into. You know what happens? X is expressed in terms of y. X is expressed in terms of y now. So that's what happens. And then I'll be able to, everything now be in terms of y. So I can now say 4 into 23 plus 4y over 7 minus 3y is equal to 11. Since this is the only fraction I have here now, sometimes it might not be a fraction. I can multiply through by 7. Multiply through by 7. So I can now say 4 into 23 plus 4y is equal to minus 21y is equal to 77. 4 times 23, that's 92. Plus 16y minus 21y is equal to 77. And you can now say 92 minus 5y is equal to 77. So let me subtract 92 from both sides. Subtract 92 from both sides. That will be 92 minus 92 minus 5y is equal to 77 minus 92. So I can now say minus 5y is equal to minus 15. Now, I can divide both sides by minus 5. Divide both sides by minus 5. So, minus 5y divided by minus 5 is equal to minus 15 divided by minus 15, minus 5. So I have this. So y equals 3. Since I know that y equals to 3, I can bring that y and substitute it here. Or I can use it in any of this equation. Therefore, x is equal to 23 plus 4 into 3 over 7, which is 23 plus 12 over 7. What does that give me? 35 over 7. So x is equal to 5. So you can see x is equal to 5, y is equal to 3. For test, I can just run it through in this place. 4x, that's 20, minus 3 times 3, that's 9. So that gives me 11. So that one is done. So that's the way to go about it. Let's check how to handle when it is more than 2 unknowns. Now we have 3 unknowns. How do we go about it? The easiest thing to do is you just look at, you pick them in pairs. Equation 1, 2, or equation 1 and 3, or equation, you can just pick any of the two and eliminate the ones that you feel like it is very simple or easy for you to eliminate, so that the unknowns will now remain 2. And from that 2, you can do the normal elimination or substitution method to solve it. Let's see how I go about this. Now, I have 5x minus 3y minus 2z equals 31. Let's call that one our first equation. 2x plus 6y plus 3z is equal to 4. Let's call that the second one. 4x plus 2y minus z is equal to 30. Let's call that the third equation. And from this third one, I can use it to eliminate z from the first and second equation easily. What do? To I will use these two to eliminate z. Let's see how I go about it. I just say 5x minus 3y minus 2z is equal to 31. Now, to achieve that, I will multiply the third equation by 2, and that will give me times 2. The third equation by 2. 8x plus 4y minus 2z is equal to 60. You can see 8x. So from here, what do? All I need to do is to subtract the first one, this one from here. I subtract this one from here, or this one from this one, anyone. So if I subtract this one from this one, that's going to give me 3x. Subtracting this one plus 7y will be equal to 29. You can see it has reduced this one to 2. Now, for the other one too, I can make it this one 2x plus 6y plus 3z is equal to 4. Now, this third equation, because I want to knock out the z here, what do I need to do? I multiply the third equation by 3 times 3. What would that give me? 12x plus 6y minus 3z is equal to 90. So you can see. Now, what do I do next? I will need to add the 2 to eliminate the z now. So I'm going to have 14x plus 12y is equal to 94. Is equal to 94. So you can see, I now have this equation and this equation to deal with. I can now use either elimination or substitution method. Now, let me bring them down now. I can now say 3x plus 7y is equal to 29. 14x plus 12y is equal to 94. Now, for ease, let me just use substitution method. From this one now, I can now say x will be equal to 29 minus 7y divided by 3. 20. So x equals to 29 minus 7y divided by 3. Now, I will now substitute this for x in this equation. Substitute. 29 minus 7y over 3 for x in 5. So I can now say 14 into 29 minus 7y over 3 plus 12y is equal to 94. So the next thing is to multiply 2 by 3. By 3. So I have 14 into 29 minus 7y plus 36y is equal to 282. So on expansion, I have 406 minus 98y plus 36y equals to 282. Then I can now say this one is 406 minus 2y is equal to 282. So the next step is to subtract 406 from both sides. Subtract 406 from both sides. So I have 406 minus 406 minus 62y is equal to 282 minus 406. So what does that give me? It gives me minus 62y. Minus 62y is equal to minus 124. Minus 124. So I have to divide both sides by minus 62. Divide both sides by minus 62. So I have minus 62y divided by minus 62 is equal to minus 124 divided by minus 62. So this one cancels this. This one cancels. So y is equal to 2. I have gotten y now. So y is equal to 2. So from there, I can now put this back into this equation to find x. Now, we have established that x equals to 29 minus 7y divided by 3. Now, y is equal to 2. So we can now say 29 minus 7 into 2 over 3. So x will be equal to 29 minus 14 over 3, which is 15 over 3. So our x is equal to 5. X will be equal to 5. Y equals to 2. Now to find z, we can substitute for x and y in any of the 3 equations. So let's use the third equation. So 4 into 5 plus 2 times 2 minus z is equal to 30. This one is 20. This one is 4 minus z is equal to 30. Now, so minus z will be equal to, okay, 24 minus z is equal to 30. 24 minus z is equal to 30. Let's subtract 24 from both sides. Subtract 24 from both sides. So I have 24 minus 24 minus z is equal to 30 minus 24. So minus z is equal to 6. Therefore, z will be equal to minus 6. So our z is equal to minus 6. Now we have another question. 5 multiplied by x plus 2y minus 4 multiplied by 3x plus 4z minus 2 multiplied by x plus 3y minus 5z is equal to 16. Another equation is 2 multiplied by 3x minus 2y plus 3 multiplied by x minus 2z plus 4 multiplied by 2x minus 3y plus z is equal to minus 16. And we have 4 multiplied by y minus 2z plus 2 multiplied by 2x minus 4y minus 3. Minus 3 multiplied by x plus 4y minus 2z is equal to minus 62. So in this situation too, we are asked to find the value of x, y, and z that will satisfy these equations. So the first thing is to open the brackets. So let's start with the first one. We are going to have 5x plus 10y minus 12x minus 16z minus 2x minus 6y plus 10z is equal to 16. So let me gather the like terms once and for all. You can do it straight. In this situation, I'm having 5x minus 12x, that's minus 7x. And this one, minus 2x, that's minus 9x. So 10y minus 4y, that gives me 10y minus 6y, that gives me 4y plus 4y. Now let's look at z. I have minus 12, okay, minus 16z plus 10z, that is minus 6z, is equal to 16. So I can leave it like this, or I can turn it to be 9x minus 4y plus 6z is equal to minus 16. So that is I multiply through by minus 1. Let's go to the next one. So this one will be 6x minus 2y plus 3x minus 6z plus 8x minus 12y plus 4z is equal to minus 16. So like I did it initially, so we don't waste time. 6x plus 3y, that's 9y, plus 6x plus 3x, that's 9x, plus 8x, that is 17x. Minus 2y minus 12y, that is minus 14y. Now let's look at it. Minus 6z plus 4z, that is minus 2z, is equal to minus 16. You can see. Now let's look at the third one now. 4y minus 8z plus 4x minus 8y minus 6 minus 3x minus 12y plus 6z is equal to minus 62. Okay? 4y minus 8y, that's minus 4y. Minus 12y, that is minus 16y. Let's look at it. Minus 8z plus 6z, that is minus 2z. Let's look at the x. 4x minus 3x, that is x. Minus 6 is equal to minus 62. Now, you can see that we still have 6 here. Let's add 6 to both sides. To move this to this side or to cancel it from this side. So we now do add 6 to both sides. So I'm going to have minus 16y minus 2z plus x is equal to n. Minus 6 plus 6 is equal to minus 62 plus 6. Therefore, let me arrange this one. It will now be x minus 16y minus 2z is equal to minus 56. Minus is equal to minus 56. Now, let me list out the equations that I have now. So you can see, listing out the equations, I have 9x minus 4y plus 6z is equal to minus 16. 17x minus 14y minus 2z is equal to minus 16. I have x minus 16y minus 2z is equal to minus 56. Now, looking at this equation, I can see that it is convenient for me to eliminate z from the equation. So let me subtract equation 3 from 2. 2 minus 3. Let me subtract equation 3 from 2. So what will that give me? To give me 16x plus 2y. So this one will cancel. So minus 16 minus 56, that's 40. That makes it very easy for me. Now, to eliminate in this instance, let me multiply equation 3 by 3 and subtract from equation 1. That is equation 1 minus 3 times equation 3. That will now give me 9x minus 4y plus 6z is equal to minus 16. This one will give me 3x minus 48y minus 6z. So invariably, I will need to add the 2. Is equal to minus 168. Multiplying this one by 3. So if I should add these two now, let me see what it will give me. This is going to give me 12x minus 4y. That's minus 52y. Adding these two now is going to give me 0. And if I should add these two, it's going to give me minus 184. So you can see, since I have been able to bring it down like this, I'll be able to work further on it. For this equation now, I can make it simpler by dividing 2 by 2, and that will give me 8x plus y is equal to 20. Looking at these two, I can divide 2 by 4 to make it easier for me. 3, that is 13, and that's, so this one too, divided by 3 is going to give me 3x minus 13y is equal to minus 46. So with this, I can now solve this one with either substitution or elimination method. If you look at this, y is equal to 20 minus x. So from this one now, y equals to 20 minus 8x. So let me substitute. Substitute 20 minus 8x for y in this equation. So I'm going to have 3x minus 13 into 20 minus 8x. So 20 minus 8x is equal to minus 46. And let's expand now. It's going to give me 3x minus 260 plus 13 plus 4 10 104 x is equal to minus 46. It was minus 46. So that will give me 107 minus 107x minus 260 is equal to minus 46. Let me add 260 to both sides. Add 260 to both sides. So that's going to give me 107x minus 260 plus 260 again is equal to minus 46 plus 260. So I have 107x is equal to 4, 214. 214 divided by 107, which is equal to 2. So you can see, from here, our x is equal to 2. Now, to get our y, I just need to substitute this x into this equation now. So, y is equal to 20 minus 8 into 2, which is 20 minus 16, which is equal to 4. You can see, very straightforward. Once you get one, you can get the other one straight. So we have gotten that our y is equal to 4. Now to get z, let us substitute x equals to 2 and y equals to 4 in any of these equations. And let me pick equation 3. So substitute y equals 4 and x equals to new equation 3. Very straightforward. You can see. So we have this one to be 2 minus 16 into 4 minus 2z is equal to minus 56. So this one is 64. 2 minus 64, that's minus 62. Minus 2z is equal to 56. Minus 56, sorry. So let me add 62 to both sides. So I have minus 62 plus 62 minus 2z is equal to minus 56 plus 62. So I have minus 2z is equal to 6. So z is equal to 6 divided by minus 2, which is minus 3. So our z is equal to minus 3. So you can see, it's the same procedure. This one just has bracketed linear expression. So anytime you come across anything that is in brackets, you are advised to first of all expand before you continue the procedures.